Hi. Today we're going to look at what are called epsilon-delta proofs. And this is what you all will have to do for your first video demonstration is an epsilon-delta proof. So you will have to kind of mimic what I'm doing here. And we can, what this means is we're going to use the epsilon-delta definition, which I wrote up here already, to show that the limit is what we think it's going to be. And first off, let me say that in general, in mathematics, definitions are made to be definitions, and they're difficult to use as tools to prove things. What I mean by that is definitions are very precise and exact, and they're made that way specifically because we have to have things that are precise and exact for mathematics. But they are generally not the best tools to prove things, and so they're difficult to work with. They're the king, and the king can be a little bit difficult to work with. So we will use this to prove some things, but ultimately in the long run, we're not going to do this very often. But it is the beginning, and we should begin at the beginning. So let's prove the limit as x approaches 2 of 3x minus 5 is equal to 1. This is what we would expect to occur as x approaches 2. 3x would approach 6. 3x minus 5 would approach 1. Intuitively, that should be their answer. We want to actually now prove it. And what we're going to do is kind of work backwards. We're going to, in some respects, cheat a little. But in the end, we won't be cheating because we'll write it the right way. But we're going to assume that we have what we want. And so this will involve some side work. And so I'm going to work backwards. And I wrote the second way I kind of listed the definition because we're going to assume that I have the then part and then figure out what I need for the if part. So let's assume I have the absolute value of f of x minus L is less than epsilon. Epsilon is just some random epsilon. Now it's some random arbitrary positive real number. It could be anything. In this particular case, we would have the absolute value of 3x minus 5, since that's my function, minus my what I want to be the limit is 1, is less than epsilon, which would be the absolute value of 3x minus 6, which, using algebra, this is 3 times the absolute value of x minus 2, which is really the absolute value of 3, since 3 is the absolute value of 3. And using my properties of absolute value, this becomes 3 times the absolute value of x minus 2 is less than epsilon, or the absolute value of x minus 2 is less than epsilon over 3. Now notice, I went this way, but all of these steps are reversible. And what this says is that if I start with the absolute value of x minus 2 less than epsilon over 3, that I end up where I want. Notice my a in this case is 2. And so if I start with the absolute value of x minus 2 less than epsilon over 3, I get what I want. This is going to be my choice for delta. When we're doing these epsilon-delta proofs, we have to actually find a delta that works. When the definition says, for any epsilon, there exists a delta. This is the key to it. We have to find a delta. That's, call it Waldo if you wish, but we have to find delta that works. And because epsilon is general, delta will also be general written in terms of epsilon, as we see over there. So now I'm actually ready to do the proof. That is side work. It is working backwards. It's kind of cheating, but it gives us the information that we need. So here's the actual proof. Let epsilon be greater than 0. Choose delta to equal epsilon over 3. That is my choice. I am picking that to be my delta. Then, if, again, this is an if-then statement. 0 is less than the absolute value of x minus 2 is less than epsilon over 3. And I'm going to drop the 0 less than part. Remember, this just means that x is not equal to 2. So we can drop this as long as we remember x is not equal to 2. That's all that part means. And we'll just basically redo, oops, how did this become? Basically redo my algebra steps from over there. We just kind of rewrite it. This means 3 times the absolute value of x minus 2 is less than epsilon, or 3 times x minus 2 with the 3 on the inside is less than epsilon, which gives me the absolute value of 3x minus 6, which is the absolute value of 3x minus 5 minus 1. Oops, that should be an absolute value. And so therefore, I have my absolute value of f of x minus L, which is the absolute value of f of x minus L. And so therefore, the statement's proven. Now, linear functions are rather simple. They will work out this way rather nicely and easily, etc. Let's do something that's a little bit more interesting. So I will erase all of this except my definition. And let's do a different example that is a little bit more complicated. A quadratic. I didn't erase very well. Suppose I want to prove the limit as x approaches 3 of x squared minus 5x plus 2 is equal to negative 4. Again, this is the logical thing. As x approaches 3, this would make a lot of sense. So I want to prove this statement. Again, I will have to do some side work. This time, the side work is going to be a little bit more than last time. So, by the way, generally, if you were reading this in a book, you would not see the side work. It would just magically say, let's pick delta to be epsilon over 3. And it works out. You, however, will have to show your side work, to show where things are coming from. But, and we'll see, as I said, the side work here is a little bit more complicated. But we still have the absolute value of f of x minus L less than epsilon. That's our ending point. So that's our starting point when we go backwards with the side work, which means in this case, the absolute value of x squared minus 5x plus 2 plus 4 minus a negative 4 is less than epsilon, which gives me the absolute value of x squared minus 5x plus 6 is less than epsilon, which this factors nicely. X minus 3 times x minus 2, and using our rules of absolute value, this is the absolute value of x minus 3 times the absolute value of x minus 2, less than epsilon. Now, the absolute value of x minus 3 is good because That is the limit that we're approaching. I want to approach as x approaches, I want the limit as x approaches 3. So that part is good. We want that. The other part is not so good. I have to have some way to deal with this. And so what we're going to have to do is kind of do some more side work. Should have given myself a little bit more room, but oh well. So let's suppose, let me do this. Let's do a big if. If we can make the absolute value of x minus 2, because that's the one that I don't have anything for, if I can make that less than some value m. Again, this is a big if. I'm not telling you how yet this was going to occur, but if we can do that, then we let the absolute value of x minus 3 be less than epsilon over m. M here has to be a positive number. If I can make the absolute value of x minus 2 less than m, where m is some positive value, then we'll let the absolute value of x minus 3 be less than epsilon over m. The reasoning being, then the product, the absolute value of x minus 3 times the absolute value of x minus 2 would be less than if A is less than B and C is less than D, then A times C is less than B times D. In other words, this is less than m and that's less than epsilon over m, then the product of this times that is less than m times epsilon over m, which magically comes out to be epsilon, which is what we want. And so, if I can make this less than m, then we have a way to make this work out. So now the question becomes, again, it's like, I solve one problem by, coming up with a solution, which may bring us to another problem, but we eventually will get to where we want to go. So I have this piece. The question then is, how can we make the absolute value of x minus 2 less than some value m? For some m. And what we're going to do is, I need some more room, and so I will, more side work. We'll go side work on the side work. What we're going to do is, we're going to restrict the values that we care about in the first place. In other words, remember, we're trying to see what happens as x gets close to 3. So let's not let x get very far away from 3 to begin with. Let's suppose the absolute value of x minus 3 is less than 1. In other words, I'm taking a distance from 3 of 1. We're only going to consider values that are less than, the distance is less than 1. Okay? So in my, whatever this picture looks like, I don't really care. But basically, here's my value, 3. I am going to restrict this from the very beginning to a distance of 1. So in that case, it's going to go from 2 to 4. We don't really care about, actually, let me do this in general. This is A, so this would be A plus 1 to A minus 1 to A plus 1. And we're only going to consider values in that region. And let's build the absolute value of x minus 2 from that. And so I'm going to have to undo this. Negative 1 is less than x minus 3 is less than positive 1. To get x minus 2, I'm going to have to add 1. And so I get 0 is less than x minus 2 is less than 2. And remember my properties from absolute value. Go back to the algebra video. We have k1 is less than ax minus ax plus b is less than k2. This means that the absolute value of x minus 2 is less than the max of k1, absolute value k1 and k2. So absolute, in this case, is less than 2. And what we have done is, voila, we have a value for m. Now, what we're doing here is kind of dealing with the absolute value of x minus 3 in two different ways. I have the absolute value of x minus 3 has to be less than epsilon over m, in this case epsilon over 2, and the absolute value of 3 has to be, x minus 3 has to be less than 1. And so we have to make sure both of those happen. But we're now ready to do the proof. So let epsilon be greater than 0. Choose delta to equal the min of 1 and epsilon over 2. Okay, it's like what I had in the last video. We need both of these circumstances to occur. If I pick the smaller value, 1 or epsilon over, in this case, my m value turned out to be 2, 1 or epsilon over 2, if it's inside the smaller, it's inside the bigger. So by doing that, that means, first off, the absolute value of x minus 3 is less than 1. Okay? And so, therefore, using the algebra I have, negative 1 is less than x minus 3 is less than 1. I'll add 1. 0 is less than x minus 2 is less than 2. So the absolute value of x minus 2 is less than 2. That's the first part. Also, the absolute value of x minus 3 is less than epsilon over 2. That's the second part. The absolute value of x minus 3 is less than delta. Delta is the smaller of these. So it's less than 1, and it's less than epsilon over 2. We're going to pick whichever one of those is the bigger of them, but it's, if it's less than, we pick the bigger of them, and it's less than the smaller of it. And so, so we pick the smaller of those, and it's less than the bigger of it. I said that backwards. And so the absolute value of x minus 3 is less than epsilon over 2. And then I do my algebra that I have written over there. Let me kind of cheat here. Use the back. So the absolute value of x minus 3 times the absolute value of x minus 2 is less than epsilon over 2 times 2, which is epsilon. And now I am right here, and we do this algebra up this way, which means the absolute value of x minus 3 times x minus 2, putting them together, is less than epsilon, which is the absolute value of x squared minus 5x plus 6, which is the absolute value of x squared minus 5x plus 2 plus 4. And that is my f of x minus L. And so therefore, the statement's proven. Let's look at one more example without all the explanation in the middle of it. And you can kind of see it worked through. So let's have prove the limit as x approaches -2 of 2x squared minus x plus 7 is equal to 17. And again, I will do some side work. We have to figure out what we need. The absolute value of f of x minus L is less than epsilon. In this case, gives me 2x squared minus x plus 7 minus 17. And absolute value is less than epsilon, which gives me 2x squared minus x minus 10, which factors nicely as x plus 2 times 2x minus 5, which gives me absolute value of x plus 2 times the absolute value of 2x minus 5. The x plus 2 is good. That's the absolute value of x minus a. 2x minus 5 I have to build, and so I'll start with the absolute value of x plus 2 is less than 1. We almost always use 1. It's just the simplest, easiest thing to use. So then, -1 is less than x plus 2 is less than 1. I have to build 2x minus 5, so first I'll multiply by 2 everywhere, and then I will subtract 9. And so that gives me -11 is less than 2x minus 5 is less than -7. And then the absolute value of 2x minus 5 is less than 11. Remember, we pick the max of the absolute value of -11 and -7. Absolute value of -7. We pick the max of K1 and K2, both an absolute value. So this is my M, which means that my delta, based on what I talked about last time, delta is going to be the min of 1 and epsilon over 11. And we're ready to do the proof. So let epsilon be greater than 0.